Welcome. My name is Lisa. I'm with the Tampa Hillsborough County Public Library, and today we are going to talk about barometers and how we can make them ourselves and what they are. So let's get started. So real quick, we're going to go over our goals for today. So our big objectives today are going to be learning what a barometer is. We're going to learn how it's used and how we kind of use it to predict weather, especially maybe our hurricane season here in Florida. And then we're going to make a barometer using recycled materials. So let's get started with our vocabulary for today. So the first word we're going to need to define, of course, is barometer. If we're building it, we need to know what it is. So a barometer is an instrument that measures the force pressed on an object by the air or the atmosphere. So air, we think of it as being a really light thing, but it does actually have weight. So you might have learned about the periodic table of elements and maybe those atomic numbers. So those are the weights of the elements, and the air is made of elements. So the air does have a weight. There's a couple of different ways that that can be affected by temperature, but we're not going to get too much into that yet today. So our next word we need to define is the thing that we are measuring. So a barometer measures the force pressed on an object by the air or the atmosphere. So that means that we're measuring the atmospheric pressure. So the air that's around you, that's around me, that's around all of the objects in our world, they press against everything that they touch. And that pressure is called atmospheric pressure or barometric pressure or air pressure. You'll hear all three of those words used. They all mean the same thing, and it's that force of the air on stuff from all sides. So it's measured in different ways. So you might see it measured in units called atmospheres. Those are abbreviated ATM. So not for money, but for atmospheric pressure, or millibars. So those are the two kinds of units that you might see it measured in. So those are our vocabulary words for today: barometer and atmospheric pressure. So let's look at two examples of different kinds of barometers. So the very first barometer that was ever invented and used was invented in Italy by Evangelista Torricelli. He was an Italian scientist, and in 1644, he figured out how to measure this stuff. So his was a long tube that was set into a pool of mercury, which we don't play with that. That's toxic stuff. But that's how he set his up. It was in that bowl of mercury and had that tube, and as the air pressure went down, the mercury in the tube went down. So this is a historic example. This is what the original one would have been built like, but we still actually use this type of liquid metal or mercury barometer today. The other kind that you'll see, and this one might be a little bit more common, is the aneroid barometer, and that's going to measure air pressure with a metal box, and that box has had some of the air taken out of it. So like imagine you've got a juice box and you've drunk all your juice out of it, and then you keep drinking and it's pulling some of the air out of it and it kind of crumples a little bit. Well, if that container is metal, it won't quite crumple. So that's kind of how they build that metal box. They take some of the air out of it, and the sides of that box, they get pushed in if the pressure outside is higher, and it gets pushed out if the outside pressure is lower than the pressure inside. So the changes in that box, they'll move a needle around a dial. So you can see how it's kind of connected in the picture there. So as that changes, it moves that dial and lets you know what the air pressure is. So this is the kind of barometer that is actually used on airplanes. So on an airplane, you might hear it called an altimeter. An altimeter is just another barometer, but it's, instead of having lines that says what the air pressure is, those lines tell you how high up you are from the Earth's surface. So those are our big examples. Those are the two main kinds of barometers, and we are going to look at how they're used. So The number one way that it's used is predicting weather. So this is really important to us here in Florida, especially or any place that has typhoons or hurricanes or cyclones. uh, a change in pressure. So whenever that pressure changes, that usually means that the weather is going to change. Now, if the pressure gets low, well, then that might mean that clouds are getting the chance to develop. If the pressure is high, or if it's a high pressure area, then that usually means that we have clear skies and sunny weather. So whenever that changes, we know, uh-oh, we're either going to get more clouds and more maybe stormy weather, or maybe it's clearing up. So we kind of track that to figure out what the weather is going to do. When we track hurricanes, that pressure rising can mean that the storm is getting weaker. So normally we get scared when numbers go up, right? Or we get nervous when numbers go up. Well, in this case, a number going up means that the storm might be getting weaker, which is usually a good sign for us. So the weaker it is when it gets to us, usually the less wind that we have. But if that pressure is falling, ooh, then that means that those clouds and that storm, those winds have a lot of chance of developing. So that's something that we really take very seriously. And we have our hurricane hunters in Lakeland, the airplanes that go up. And remember how we said that one of the barometers that we looked at is used in airplanes to measure altitude? Well, our hurricane hunters might actually use both kinds of barometers for what they do. Because the other way that it's used, of course, other than predicting weather, is measuring altitude. So an airplane that is tracking hurricanes is going to use both kinds of barometers. Get our examples here. So on this picture here, you can see a picture that shows as that pressure goes down, the clouds can go up because there's not as much atmosphere pressing down. So if the atmosphere is not pressing down from the top, those clouds can go up. And as they get up, they get stronger. So if there's a lot of pressure there on the top, then that's keeping those clouds down, slowing it down a little bit. And here's a picture of one of the hurricane hunters. So those are just up the road from us here in Hillsborough County. They're just the county over in Lakeland. So it's nice to have them so close by. All right, we're not going to go very in depth here, so we have enough time to do our activity, but there is math involved because we know exactly how much our planet's atmosphere weighs. So that this is the mathematical formula that you can kind of look at to calculate how much the atmosphere weighs. This is something that you might want to keep in mind if you're studying exoplanets and maybe you're looking at your instruments and seeing what is in the atmosphere in a planet. You might be able to determine how much that planet's atmosphere weighs and if it might be a little bit too heavy for us to breathe easily, for example. So that can be used for planetary exploration as well, not just for our local weather and storm prediction. All right, so remember, as we go along, get those questions into the chat box. Let me know if you have questions as we go along, because we are going to jump right into our activity for the day. So I'll go over really quickly what our supplies are. We want a jar, and it can be any kind of jar. It can be a plastic jar, it could be a glass jar, but you want something with a fairly large opening so that you have plenty of room to stretch your balloon or your plastic wrap. Or in my case, I didn't have a balloon and I didn't have plastic wrap, so I used a rubber glove or like a medical glove, a nitrile glove. You'll need yarn or string to attach it to the jar. So if it's not something that's already easily stretched over it like a balloon and it's something that's loose, you'll want that yarn or string to attach it. And then you need either a drinking straw or a light stick, like a bamboo skewer, something really light that's going to sit on the top. That's not going to be so heavy that it can't rise and fall. So you want it to be really light, but something that sticks out over the edge of your jar. And then some tape, or you could use glue to attach it, some scissors to make your adjustments, and some cardstock or sturdy paper that you're going to use to kind of track that and make your graph on it. So I've got our little QR code up there. After we finish this program, I will send our video over to our team who's going to edit and clean it up and post it to our YouTube channel. So if you're not able to follow along at home with us today, you'll be able to follow along on our YouTube channel. We'll also have our activity handout with all the instructions in it. I'll put those in the chat at the end of the program so that you can download those, but they'll be available on our YouTube posting as well. Now let's jump in and look at our first steps. So the first two steps are we're going to take our balloon or the palm or the big section of our glove, and we're going to stretch it over the opening of the jar. So you can see I just have a container that had some fancy rice in it. You can use any kind of jar. That's a nice plastic one, so it's really lightweight and it was easy to hang on to, and I didn't have to worry about dropping it or breaking it. And then I took my glove, and because I didn't have a balloon and I didn't have any plastic wrap handy, so all I did was cut out that the big hand section of it. Basically cut off the fingertips and then cut along the side to make a nice springy rubbery sheet. So just remember when you're using scissors, remember to keep it away from your fingers and ask a grown-up for help if you need it. Just cut off the fingers at the end there and then just kind of cut along the side. And then so you have that springy sheet. You're just going to stretch it over the top of your jar, just like that, just to make sure it fits. Now mine covers up more than just the edge of the jar. You want it to hang over at least about an inch or so, just to make sure you have enough room to really attach it well with your string or your yarn. And I just had, this was just a piece of scrap yarn that I had left over from a crocheting project. So any kind of string will work for this. It can be gardening twine, it can be an extra piece of string, an old shoelace, anything really, just something that will secure that either rubber or plastic sheet to the top of your jar. And when you tie it, most jars have that little bit of a lip, so that there's the screw part where you would screw the lid on, and then it usually indents a little bit right below that. So you want to tie it off right below that where it's indented a little bit, because that's going to keep it from accidentally sliding up and popping off of the top. You see, I had some technical difficulties tying my knots there, but I eventually got it adjusted, and then you just go around the edge and kind of pull it snug. So once you have it all pulled snug, it'll be nice and tight, and when you tap it, it'll sound a little bit like a drum. And that lets you know that you've got a nice amount of tension on there. Hop over to our next slide. So once you've got that done, you're going to attach that indicator or that pointer on top. All right, so you see we're just adding a little bit of color to the end of our clear straw just to make it a little bit easier to see once we have it attached at the top. So if your straw is the same color as your background or clear, you might want to add that just to make it a little bit easier to see. And once you have it on there, you're going to put it in, just about the center. It doesn't have to be exact. But then you'll take some tape, and you can use regular paper tape or Scotch tape or washi tape, any kind really, just to attach that to the top of that membrane on top of your jar. Yeah. And you see I didn't measure it. You just kind of loosely place it there so that the end of it is not at the edge, but hovering just right around the middle. So I don't know, what do you think? Is it a barometer or is it a baby Dalek? Could go either way. Yeah, so that's our third step. And so we're ready for steps 4 through 5. So now we're going to get our little chart made up so that we know what it's going to point to. So you can use cardstock or junk mail or anything really. I used, I had an old manila file folder, and it was a little bit torn up on the one side, so I just used the half of it. And I kind of marked where that indicator is, where the pointer is, just to make it a little bit easier to see. And then once you have your pointer and you have your chart there, you're going to mark it like that and just make little marks to show a rise or a fall. So as there's more pressure on the outside, it's going to push down on that membrane, which is going to cause your pointer or your indicator to go up. So that might show that you're going to have a sunny day with few clouds. But if the outside pressure is low or it drops, then that means that the inside pressure in your jar is going to be higher than the outside. So it'll push up just a little bit and make a little bit of a bubble, and that will cause your pointer to go down. And that might mean that you're going to have some cloudy weather or some rainy weather. So you can see this is not going to be a super duper precise one. So we don't actually have exact millibars or atmospheres marked on there. We just kind of want to see if it goes higher or lower than it was when we started. And then we can look outside and see, does it match? So as that pressure went up, did the day get sunnier? Did we have fewer clouds? Or if the pressure went lower, if it dropped, we can look outside and see if maybe we had some cloudy or rainy weather that came in that matched that. So if you download the handout for this activity, there's going to be spots for you to record your observations and make a note of what you observed, if the barometer went up or down, what the weather outside looked like. And if you have a thermometer that you can use for this, you can place it next to your barometer or maybe just outside and maybe record the temperature as well and get a full picture of what the weather day looked like outside. So that is also an option. All right, so that was our steps 6 through 7, and we have gotten through our activity assembly. So you can see this is a really easy one to assemble. It is going to be something that you can make with stuff that you have laying around the house, which is always nice. We like to be able to reuse things. So with that activity out of the way, remember you'll be able to download that handout. I'm adding it to the chat box now. You'll be able to kind of follow along. It has the instructions and the supply list and a spot to record your observations. But if you want to learn a little bit more about how barometers and weather work together, how we can use those together to kind of predict what's going to happen, you can check out these 2 books on Hoopla. So the first one is Understanding Hurricanes by Olivia Williams, and the other one is Barometers and Hygrometers and how those are used. So both of these are geared towards school-age kids. Definitely check those out if you want to learn a little bit more about this topic than we had time to cover today. You can find those at hcplc.org/ebooks. If you go to that and you just type in barometer in your search, these are going to be among your top options that pop up on the page. And there is our Q&A time. So if you have any questions, drop those into the chat box. We would love to answer them while we're live on the air. If not, you can always reach us at hcplc.org/contact. That has all of our contact information, including our phone number, 813-273-3652. You want to find more STEAM Time events coming up, you can find those on our calendar at hcplc.org/events. If you just type STEAM into the search box, that'll pop up all of our STEAM related programs. Our next one coming up is actually going to be later this month on the 24th. It'll be Wednesday the 24th, and we're going to be going into Fiero Code and learning about code blocks. So we've had one Fiero Code program previously that kind of gave us an idea of how we can get logged in and how it works in general. And with this session, with the code block sessions, we're actually going to go into one of the modules and learn how to do that. We're going to work through it together and figure out how to get started with that code block activity in Fiero Code. And then next month in June, just in time for summer reading, you might want to write your friend from school a secret message. And if you want to learn how to make some invisible ink to do that, join me on Tuesday, June 13th at 6 o'clock. We'll have a little invisible ink making activity and we'll learn some of the chemistry behind how that works. So I hope you can join us for those 2 programs. Thank you so much for attending, and we will see you soon for our next STEAM Time program. Good night, friends.